Good afternoon, my dear students, and welcome to class number 10. Electrostatic class number 10. So, in previous class, we have already discussed validity of Coulomb's law and relation between Coulomb and start Coulomb and Coulomb and up Coulomb. That already finished, and also I have told that the validity of Coulomb's law, but one things about the Coulomb's law is one thing's amount of about of Coulomb's law is remaining, but today some things about Coulomb's law I will discuss. Make a heading. After validity of Coulomb's law, you can note down limitation of Coulomb's law. Yes or no? Limitation of Coulomb's law. Yes or no? It is applicable for point charge. Point charge. It is never applicable. It is never applicable at distance 10 to the minus 5 meter or 1 for me. 1 for me is equal to 10 to the minus 15 meter. It is a very important point. It is never applicable at a distance 10 to the minus 15 meter or 1 for me. We know in the Coulomb's law, we have to calculate or we determine the force between two charges. That means there is some distance between two charges, then we can find out the force between two charges. But distance between two charges, something two charge, this is the charge 1, this is the charge 2. Distance between the decreases, then force is increases because F is equal to beta Q1 Q2 R square. Whenever distance increases, force decreases, but distance decreases up to this. That means whenever distance between two charges becomes 10 to the minus 15 meter, then there is not force act on each charge because there is not validity of Coulomb's force. Coulomb force is not applicable at a distance between two charges each 10 to the minus 15 meter. Suppose example, charge 1 Q, charge 2 Q2. Two charges distance between, suppose 2 into 10 to the minus 6, 10 to the minus 16. Suppose what is the force act on this charge? There is not act on force on this charge because the distance between two charges is the 2 into 10 to the minus 16 meter is greater than 10 to the minus 15. Yes or no? So Coulomb force or Coulomb's law is applicable whenever R less than 10 to the minus 15 meter. Whenever R equal or greater than 10 to the minus 15 meter, then there is not Coulomb's force is created. That is the properties of what? Coulomb's law about Coulomb's force about two charges. That is the limitation. यहाँ पे distance, whenever distance between two charges is greater than or equal to 10 to the minus 15, then Coulomb's law is not applicable. There is not applicable of Coulomb's law or Coulomb's force. That is the basic drawbacks of Coulomb's law. So that's why the limitation of Coulomb's law is what? It is never applicable at a distance 10 to the minus 15 meter or 1 Fermi. 1 Fermi you have already known in first year class. 1 Fermi is equal to 10 to the minus 15 meter. Yes or no? So distance between two, you have to remember distance between two charges. If distance between two charges is greater than or equal to 10 to the minus 15, then there is no applicable of Coulomb's law. That means there does not act on force on each charge. Yes or no? That is the limitation of what? Minus 15 meter or 1. Then now we will discuss the superposition of Coulomb's law. Superposition of Coulomb force. Principle of superposition. Yes or no? So make a heading: superposition. Principle of superposition. Principle of superposition. Superposition means what? Suppose you have already known in your first year class. Suppose it is the point. Suppose the force act on this point is F1. Yes or no? So another force is act on this force F2. Yes. So another force is act is F3. This is the vector quantity, this direction. Yes or no? But question will ask you the net force or resultant force act on this point. What is the value of resultant force act on this point? The value is what? Suppose F is this, F2 is this, F3 vector is this direction. Suppose resultant force is F. Resultant force is Fr. Is named as Fr. So we can write in vector form. You can already know in first year class. Resultant force Fr is equal to F1 vector plus F2 vector plus F3 vector. Yes or no? So we can write principle of superposition means the vector sum of individual force. The vector sum of individual force is known as resultant force. That is the principle of superposition. Yes or no? Yes or no? So we can write principle of superposition. Suppose Q in charge is here, Q2 charge is here, Q3 charge is here. Yes or no? So Q4 charge is here, but here Q5 charge. But my question is that we have already known by help of Coulomb's law, Coulomb's force can be determined between two charges. Here more than two charges are there. 1, 2, 3, 4, 5. Yes or no? So my question is that here it is the charge is Q1, it is the charge is Q2. So force between two charges are present. Force between two charges are present. But my question is that the net force act on this charge 5. चार्ज 5 उपरे चार्ज 5 पॉइंट उपरे केते टोटाल बल पडुची That means we know Q1 charge is here, Q5 charge is here. Suppose this is the positive charge. Suppose this is the positive charge. But 2-point charge here. That means whenever force act on this charge is what? This direction due to Q1 charge, force act on Q5 charge is this direction. This is this direction. This force is named as F51 vector. F51. Force act on Q5 due to Q1. This is the force F51 vector. Listen. Similarly, the Q2 is the Q2. Suppose Q2 is here. Q2 force act on Q5. This direction. That means this force is named as, this is the positive, this is the positive, this is the repulsive force, because force act on Q5 is this direction. We have to say also force act on Q2 charge this direction, but now we have to calculate net force act on the Q5. So that's why we have to show force act on this charge. Yes or no? So due to Q2 charge, force act on Q5 is what? F52 vector. Similarly, Q3 is here, Q5 is here. Yes or no? This force is what? Force 5, 3 is here. Similarly, Q4 is here, Q5 is here. Due to Q4, force on Q5 is what? F5, 4. So again redraw. Force is F51 vector. This is the force 52 vector. This is the force 53 vector. This is the force 52 vector. This point charge is Q5. On this point, individual charge due to individual charge means due to Q1, due to Q2, due to Q4, due to Q3. Yes or no? Again, I can repeating due to Q1, due to Q2, due to Q3, due to Q4, due to Q4. Net force is act on Q5 is what? That means force 5-1 direction is this direction, 5-2, 5-3, 5-4. But resultant force act on Q5 is, I can write resultant force F1. Resultant force is equal to vector sum of total force. That means F51 plus F52 plus F53 plus F54. Yes or no? That is the superposition of principle of superposition. Yes or no? Similarly, we can write similarly n charges are available. N charges are similarly for n number of charge. For n number of charge, then Fr is equal to F51 vector plus F52 vector F5n vector. Yes or no? This is the basic idea of principle of superposition. Yes or no? So you can write. So we can write statement of principle of superposition. So write down, it states that number of charge are placed, number of charge number of charges are placed near each other, near each other behaves independently the total force or net force due to one charge, that means due to Q5 charge, due to one charge with respect to other is the that means force due to one charge with respect to other. That means due to Q1 charge, force is F51. Due to Q2 charge, force act on Q5 is F52. Similarly F53, similarly F54. If number of charges are there, n number of charges are there, F12, F51 plus F52 plus F53 plus F54 dot F5n. Listen. So total force due to one charge with respect to other is the vector sum of forces. Vector sum of forces of different charge with respect to one. With respect to one. According to Coulomb's law. Yes or no? According to Coulomb's law. This is the statement of principle of superposition. Yes or no? Suppose two forces are there. Suppose two forces are there. Suppose this is the force F12 or F51. Suppose this force is F52. This is the angle between F51 and F52 is this direction. The resultant force is question will ask resultant of these two vectors is what? Resultant of is what? Net force. We can write due to principle of superposition, Fr vector is equal to vector sum F51 vector plus F52 vector. Yes or no? So magnitude Fr vector, Fr means resultant force. Fr vector magnitude we can write F51 square plus F52 square plus 2 F51 F52 into cos theta. Yes or no? It is the force between two charges. Suppose two forces are there, F resultant is. When three forces in vector sum of 3, four forces vector sum of 4, but two forces vector sum of 2, but we have already known the ETH, we have to determine the magnitude of the resultant force this way. The F51 it already you have already known in first year class. F51 square plus F52 square this direction. Yes or no? This is the formula. in you have already known the physics formula. You have already studied in first year class. So then we can, but now then after it study we will discuss the distribution of charge. Yes or no? So I will discuss about distribution of charge. Distribution charge means charge is distributed. Charge is distributed. But in our inverse, the every charge is greater than point charge because any charge is distributed continuously. That is called continuous charge distribution. So we can write in our inverse every charge greater than point charge. That means the charges are, you can write charges are continuously distributed. Charges are continuously distributed in linear case or linearly, you may write linear surface, and this may and symbol volumetric. Volume. Yes or no? Linear means what? One straight line. Linear. Charge is distributed in a line. That means in a linear case. That is the linear charge distribution. Similarly, surface I will discuss. Yes or no? So, the first you have to write linear charge distribution. Linear charge distribution. Yes or no? The charges are continuously distributed. Along a line. Is known as linear charge distribution. Linear charge distribution. Linear charge distribution. Suppose this is the reference x-axis, y-axis. Suppose this line is present with the L distance. This is the L distance. Suppose we have to choose this direction. Total the L. This line we have to select. This line is what? DL. That means in the L distance charge is provided Q. In DL distance charge is provided DQ. This is the position vector. This one. So we can write the lambda is what? Lambda is the linear charge density. Linear charge density is what? Linear charge density is the charge per unit length. That means lambda is equal to dq by dl, or we can write lambda is equal to q by l. We can write, but in we have to choose in small length or small charge. So the linear charge density is equal to charge per unit length. So we can write lambda is equal to dq by dl. Lambda is what? Linear charge density. Linear charge density. dq is what? dq is the charge at length dl. l लेंथ में चार्ज क्यू होता है, क्यू. l लेंथ में चार्ज क्यू, बट स्मॉल लेंथ में चार्ज dq होता है. ये सुन. So we can write the linear charge density. Linear charge density lambda is the linear charge density. The dq by dl. So dq is the charge at length dl. So we can write dq is equal to lambda dl. So we have to show the total charge in length L is what? Q. Total charge is Q. Q is integration of dq. We have already known about the integration. Yes or no? Here dq is equal to lambda dl. So q is equal to integration of dq or lambda dl. So q is equal to integration of lambda dl. We can write. Yes or no? So unit is what? Charge density. Unit of charge, unit of lambda. Unit of lambda. That means unit of charge density is what? We know unit of charge density is what? Unit of charge density. Lambda is equal to dq by dl or coulomb per meter. Coulomb per meter. ये सुनो, डायमेंशन कितना होता है? डायमेंशन क्या है उसका? डायमेंशन है कूलम. दैट मीन्स L1 T1 डिवाइड बाय L1 OM0 L1 T1 T1. Sorry, L1 minus 1 T1 A1 T1 A1. Yes or no? This is the linear charge density. We will discuss about surface charge density. Yes or no? By adding surface charge density. Surface charge distribution or density. Yes or no? Surface charge distribution. It is also same. You can write the charges are distributed over the surface. It's called surface charge distribution. You can write charges are distributed. Charges are distributed over a surface is called surface charge distribution. Surface charge distribution. So the reference x-axis, y-axis are present here. The area, that means suppose this is the surface area S. The small surface area is the positive charge. Suppose surface area is here S. The small surface area is known as ds. The S surface area, if in S surface area charge is q, then ds surface charge is dq. Yes or no? So we can write, due to surface charge distribution, the surface charge density is available. The surface charge density is what? Surface charge density is there is equal to dq by ds. Yes or no? The linear charge is lambda. Linear charge density dq by dl. Linear charge density. Charge per length. Linear. Linear means straight line. Yes or no? But now surface. Surface means area. Surface means area. That means एरिया में चार्ज है पर यूनिट पर स्मॉल एरिया में कितने चार्ज डेंसिटी होता है. सो लिनियरली dq by dl surfacely dq by ds. ds means small area. That means their lambda is the surface linear charge density. Similarly, we call there is the surface charge density. So we can write there is equal to dq by ds. So dq by ds, there is what? Surface charge density. ds means small area. dq means charge at small area, small surface, small area, ds. Yes or no? So we can write dq is equal to del ds, or q is what? Integration of dq is equal to integration of del ds. So q is equal to integration of del ds. This is the surface charge density. Yes or no? So from the surface charge distribution, surface charge density is created. So it has also unit and dimension. So you can write unit is what? There is equal to q dq by ds or q by s. dq means coulomb per area. Unit of area is meter square. So dimension is what? Dimension is coulomb. Dimension is formula. What is the formula? Del is equal to dq by ds. The dimension of dq, q means coulomb. So dimension of coulomb A1 T1 divided by area. Dimension of area L square. So M0 L minus 2 T1 A1. That is the unit dimension of surface charge distribution. Then we can write volumetric charge distribution. Similarly, we can say the charge distributed in volumetric.